So maybe some of you still know Sendung mit der Maus, and there they explained the internet in a wonderful manner, and it was not that many meters they had to travel to carry a package. This was back in a time where the internet indeed was a bit more efficient and not controlled by a few monopolies. So we hope that this could be in the future again an internet where not just a few companies are responsible for routing packages and so on, because nowadays when we sit next to each other, it could be that our packages travel way longer than we would ever expect, which has a lot of negative consequences, as we will hopefully hear in the next talk that is held by Tassilo and Klemens. So a warm welcome to Tassilo and Klemens. Yeah, I wish you a pleasant presentation. So I pass the mic.
Thank you, Vince Lieb, for this nice introduction. So our talk, DDX, how to construct a more decentralized internet, hopefully in theme for this conference. You maybe ask, why? Vince Lieb maybe already highlighted a bit why, we should do something. But in this talk, we want to talk. I want to first motivate why. What Vince already touched upon. The internet is slowly consolidating. There are larger ISPs, larger content provider networks, and it's also it's becoming splintered. A good example, for example, is China or Russia is also becoming more and more isolated. So we have both of these trends, and the question now is, what could we do about it? For people interested, there's a good talk with the study from Matthias Welisch, another one of our co-founders. So what is an IXP? What function does an IXP have in the larger internet? How does an IXP work? And why you maybe should also found your own in your city and to combat those issues. And with that, Klemens will explain a bit of the first two questions on what is an IXP and what function does it serve.
So let's start with the question, what is the internet in the first place, right? So the internet is a decentralized network of computers, or in a more applicable sense, internet is a network of other networks, right? So essentially you connect many computer networks together to form one big internet, right? So let's imagine how it works. So essentially you have all of those networks. For example, DVB runs a network that is our local transport provider. And you, for example, have the university who also run their own network. So now you want to send packets between the university and the DVB, for example. And what you start doing is connecting networks with each other, right? So internet is all about connectivity. It enables connectivity, and that in a globally application independent way, right? Every network has an IP address range, right? So they have a prefix. For example, the university starts with 212.111.251. And inside of this prefix, they have a few addresses allocated to them, right? Now, what they essentially do is that they have to announce those IP addresses between each other. So every part of the internet, every autonomous system is what we call those clouds here. Every network has to announce their addresses to their neighbors, right? So that the neighbors are the networks they are physically connected to. Because as you can see in this example, the university is not connected to the DVB directly, but as you can already see, there are path forms over other autonomous systems. So at the edge of each of those networks, you have a router which connects to the other edges. And those are essentially physical connections, right? And each of those networks then exchanges the information, what prefixes it has, and also their individual routing policy. And by this, essentially moves that information through the whole network, right? So let's talk about BGP, the Border Gateway Protocol. This is essentially the protocol each individual autonomous system, each subnetwork, if you want to call it that, uses to exchange the IP prefix information, what prefix do I have, and also configure their individual policies based on the information they receive in order to figure out which way they can route the packets, right? So each of the other autonomous systems has to keep track of all the announced information, and using that we can figure out ways to route packages. For example, in this case, the autonomous system on the upper right corner, if it wants to send a package to the DVB, it first of all has a direct connection, that's a physical connection. But if, for example, this connection fails because it got destroyed or it runs into some kind of issue, we can route through the package through other autonomous systems in order to also reach the DVB, and that way we have a fallback and we have that redundancy that we want in order to keep the traffic going. So where do IXs come in? Because essentially every ISP, every internet service provider, every big commercial CDN and also very big hosters probably run their own autonomous systems, and they could just connect themselves to each other, and you would have some kind of internet, of course. But so the main issue is that let's imagine Dresden, for example. Let's imagine a data center in Dresden, and you have like 8 parties who each run their own network, their own autonomous systems, and they want to connect to each other. Now, each of these peers, is what we call them, would have to have 7 peerings, because it would have to have 7 connections in order to reach every other autonomous system. And you just run into a big mess of peerings. So in this case, every peer has to have 7 peerings, and you run into a total of 28 peerings. This also means that each party has to allocate 7 ports, or at least have to have 7 BGP sessions open in order to be able to reach everybody. And you kind of also run into an issue if only one of those connections fail, because now that peer cannot connect to the other ones again. Now you could run redundant connections by just having 2 wires, 2 fibers, for example. But I mean, you're just making the problem worse at this point. And also, if you have more peers and more parties that you add onto this, essentially the amount of peerings you need scales exponentially, right? So because of this, we add IXs. And we add 2 route servers. This is, of course, for redundancy reasons, between all the peers. And now, per peer, we only need 2 connections in order to have a redundant connection to our IX, which also forms an autonomous system, right? And that way, you drastically reduce the amount of peerings that you need in order to reach every other party, right? And we only have 16 peerings now. And also, this scales way nicer when you add more parties, because everybody at all time only has to allocate 2 ports, right? So let's talk about what an internet exchange point is. It's essentially just a bunch of switching infrastructure with a route server, and of course a community that worries about that IX, right? And let's take a look at an actual example. So our issue was that we had 2 ISPs that run servers in the same city, essentially, the same in Dresden. But if you try to communicate from one server to the other server, because there was no direct connection between those 2 ISPs, what would have happened is that you sent the package to Berlin, Berlin sent the package to Frankfurt, Frankfurt would send the package back to Dresden, and you just went in a big circle for no reason at all, right? It's pretty useless because you add a lot of latency, and also it's a cost factor because sometimes you will have to pay exorbitant transit fees and so on, right? So what we did is, since we added the DDIX and we added both of those ISPs to that exchange, reduced, essentially we only have 2 hops now, and the package essentially stays in Dresden, which has way lower latency and is just, it just makes more sense. And this is also where our motto, keep local traffic local, comes from, because if you try to communicate in Dresden, you shouldn't have to go through the entirety of Germany, right? It just doesn't make much sense. Also, another thing we're trying to fight against is the ongoing consolidation. So the issue is that big hosters and big CDNs become a bigger fish, and there are a few very, very big, hosters, CDNs, and ISPs who also expand globally, and by that essentially can influence the internet way more, because the original idea of decentralization becomes muddy, right? Because now we have a few big players who control lots of the traffic. And sadly, this is also a thing we noticed that IXPs are doing, where they also expand globally and, kind of push out local ISPs, or at least local IXPs, right? So the package routing becomes very much centered on a few providers, right? And we've founded the DDIX as a small pillar of strength against this, development. Right. Yeah. So Tassilo is going to move on and talk about what the Internet Exchange is made of.
So Klemens talked about what role it plays, and I'm going to talk about how you can build your own and why you should. And everything starts with a switch. You have a switch inside one of your POPs. POP is the industry term for point of presence. So this can be a data center inside your city, where you have infrastructure. You install your switch. You add your root service to exchange routing information with all your connected peers. So your peers, by a peering port formula, connect to your switch, and then they can connect to your root servers and get routes from all the other peers connected. There is different technologies. So for example, at DDX, we operate 2 POPs. This scales to many, many more if you want to. And basically there are protocols like, for example, EVPN, VXLAN, to virtually basically create one logical switch out of multiple. So you can also basically connect different peers to the same AX that are conceptually at different locations inside your city. And then you, of course, you connect your peers. They buy cross connects into your rack. You connect them. And so they basically have access to the switching infrastructure, and then they can also basically set up BGP sessions with our root service to get the routes. And so there's a lot of software involved. And for people who want to found an IX, this is maybe a bit confusing. So for example, the IXP manager is, for example, the portal that all our customers use. It's an industry standard tool that people use as a front end for IXPs. So that's where people put in their ASNs, they get assigned their IP frags from the peering LAN. They put other things in, like, for example, Ethernet, MAC address secrets for checking, for example, the BGP sessions. And then the second, of course, very important piece of software is a router. At DDX, for example, we run Bird. There's also other alternative. For example, there's also, when I originally started DDX, I, for example, was very confused and needed like a week. For example, what is peering manager? For example, that's a piece of software that you don't need. That's, for example, for ISPs and not for IXPs. That's what, for example, our customer sees. So this is this portal. You have graphs. You have all your information. You see all the other networks that are available. Routers, you basically can choose between 2. Either you, for example, go for Bird. Bird is easy to configure. Or the other one is FRR. FRR, it's a bit cumbersome sometimes to configure, but the main things that they do is they keep your routing information from all of your peers and distribute it to other and do additional things like a modern feature or recent thing that is becoming industry standards is RPKI route filtering with ROAS and BGPsec and so on. But it's not only, you don't only need to think about the software that you need to run your IXP. There's a lot more involved. You need cloud for for example, like a Nextcloud for your customer management. So, and that's, for example, how it looks for us. You need authentication, Nextcloud, ORM stuff, and all of this stuff. And that's, for example, all the networks that we maintain are here in this schematic, and some of the services, because you need way more wikis and so on. And the other thing is, of course, the community building. You should try, if you create an IXP, you should aim for, building, an actually tight-knit local community of different network providers that can work together. The internet at the end is a collaborative project, because all of those different network providers need to talk to each other, need to agree on things. You get very cool, synergy effects, that one provider has a problem, the other one has a solution for it. There's an exchange of information, not only an exchange of traffic. So embrace the power of friendship. It's pretty cool. You should also do it if you build your own IXP. So nice. How can I build my own? Next thing, I will talk a bit about our story, how we did it, and steps that you can follow if you want to build also your own. The first thing is speak to people. I know this community, a lot of people who like to enjoy being in their basement, little basement dwellers, go outside, touch grass, go to your local RIA meeting. RIA is Regional Internet Registry. For Europe, this is RIPE. For US, it's ARIN. For Asia, it's APNIC. They most of the time have meetings every half a year, every year. For example, I got the RIPE fellowship. I was able to travel free to Belgrade, talk to people, met a lot of people that explained a lot of stuff to me. Also met people, for example, from Berlin that knew people from Dresden who are also interested in doing this. So you can actually find other people that are also involved in this project, or your network operator groups if there's already one, or even your local hackerspace. Second is you need to find people with actual, power, resources, money that want to support your project. This is a selection, for example, of the people who contribute, or companies that contribute quite a lot to DDX voluntarily. Find those stakeholders. Most of them, if, for example, no IX already present, have an interest in supporting those projects. And this can be everything from local ISPs, your local hackerspace, to your local university, to fiber providers. Most of them have an interest in building local internet infrastructure. Get your numbers and resources, internet resources early. You don't have to become, for example, a full member of RIPE. This is very expensive. You can find, for example, in Europe, there are sponsorship programs. If you want your own ASN, this costs you, if you have a sponsor, $50 a year to get your own ASN. And then, of course, you also need the IP prefixes for your peering LAN that you can assign out. So try to get this early. So if you can actually get going with building infrastructure, you already have all the numbers assigned to you. Last thing, you need a legal entity, you need all the stuff, you need banking, you need, some way so you can legally be. We are a German like a club, ein deutscher Verein, a German association under law. There you also don't need to reinvent the wheel. Our documents are all on our website, link at the end. You can actually borrow from them. We borrowed a lot, for example, from BKIX and other clubs, from even like some documents from CFD2. You don't need to reinvent the wheel, adjust it to your needs. It's easier than you think it is if you never founded like a German association. And also, of course, if you need banking stuff, do this early, right after your association, your founding. You should go to your bank, get yourself a bank account. Otherwise, it takes longer to get working. And then, of course, teaching. We had some very experienced members at the beginning. We had people at the beginning who had no clue how the internet works or what an IXP is. We did basically how we teach other people basically by two main means. One is what we called hack days. Those were at the beginning. We basically locked ourselves in like on a Saturday afternoon and took something like, rolled out a switch and played around with the Arista switch config or configured the root servers. do this in a collaborative manner so you get everybody up to speed. It is very important for those community-driven projects to have like the next generation of people already in the pipeline training, so that if you basically don't have time for it anymore, they can take over. And the second vehicle that we did is open tech meetups, where most of the time we do them in university, where we invite like all the network operators from Dresden and different stakeholders that are there, and we have like some community talks, some updates, and then most of the time we go like grab dinner together afterwards. And then build. One of your key advantages if you found a new IX is that you basically have a greenfield deployment. You have nothing else, you have no customers yet that can be angry at you if your root server or switch goes down. There's nobody yet, so you can actually be quite innovative about it. You can try new things that, for example, are not industry standard yet, and actually push the envelope a bit. And that's, of course, quite appealing. So you can, and that, for example, also could become one of your potential selling points to potential customers later on, that is actually fresh and new, and not some old Cisco deployment where everybody where everybody goes around the world, configures all the switches and routers individually. And last but not least, last point is, it is very hard for an IX at the beginning to acquire customers. What you basically sell is the connection to other networks. If no network is connected at your IX, you basically have no value. So what you should definitely start with is basically the companies and people and networks that support you from the beginning. If you don't have them, like this initial base, it becomes very hard. Like people who do it for, idealistic reasons at the beginning, those are the people that you want really at the beginning, because otherwise you have no value. And then you have some value, which is, for example, the other things you can offer. So if we are, for example, a very young club, there's, for example, I don't know, you can offer different things to them, like presence on your website, or those kinds of things to make it more enticing for your first customers before you actually get rolling. Yes. We started writing also those advices down in a RIPE. Basically, RIPE has this blog article series, this blog called RIPE Labs, and we have an article series there called RIPE Labs, where we also go substantially more into the technical details on how an IX is built. Those are the 3 articles that are already released. We plan to do definitely 4 or 3 more that touch on different other topics than those. But this is also very good for reading. And if this doesn't help and you're around, on the 25th of November, we have one of our open tech meetups at the university. And if that doesn't help, there's our mailing list. Write us if you need help with building your own. If you're interested, I'm happy to sit in some call with you and walk you through and give you some advice. And that's it. That's our talk, a bit on how we build DDX and why you should maybe build your own inside your city. Thank you.
Yes, thanks a lot for your great report, for your great presentation. So who of you is now ready to set up IX in an exchange in his own town? But maybe there are some questions, so...
maybe please. I didn't do a good enough job, but maybe the questions help.
Yeah, maybe the questions help, and afterwards you're ready.
Thank you for your talk. My question is, there, to my knowledge, are not many IXs. So Nuremberg, Frankfurt...
Yeah, I think in Germany it's like 16.
Okay. But if you take that for cities, there are a lot fewer IX than cities.
Yes.
So is there not some kind of will or push for cities to have their own IX? Is there some kind of support for that?
The problem is, of course, you always need to have somebody who wants to do it. And for us, for example, luckily we were the people, like the companies were interested in having one, in their city, but they didn't want to invest the money or manpower in doing so. And that's, for example, why we basically got all of this support, because we were young, wanting to do this. And they were, okay, sure, here you get some money, here you get some free rack space, go, have fun, right? But I think there is basically, it's of course a bit depending on which city you're on. If your city basically doesn't have its own, network provider or so on, this of course gets harder. But there's a size, I would say 300,000 people where this basically starts making sense to build your own, at least in Germany.
Right, and then I might also add that you can imagine that the IBH was actually trying to build an internet exchange. I think it was 2006,
they
right?
They basically tried to build one in 2007. Well, at that point it was called DD6. But for example, at that time the ecosystem locally was not developed enough that this was able to survive.
Right, and also you gotta kind of imagine that if you as a company do this, not as an association, but as a big company, as a commercial company, that some other companies might be, they might be a bit afraid, because it could also just seem like you're trying to cut costs, right, and or cannibalize their business, right? So it's always kind of a bad look if an ISP, for example, creates an internet exchange.
Yeah. And that's, for example, one of the big benefits that we have, because we are basically this association that is, independent from all of those different companies. We are basically a neutral point where you can do interconnection.
Okay, thank you very much.
I hope it answered your question. Cool.
Has there ever been a push for replacing BGP with something better? It's a protocol from the 80s, I think. And
BGP is completely and that's, for example, the point of the RPKI on the router slide that I made. There are extensions now, for example, resource origin authorization, which basically, for example, filters what the industry calls hijacked routes. So if you illegally announce a prefix, those ROAs, for example, are a way to filter those routes and don't propagate them. And there are more and more extensions. ROA was the first one, then BGPsec, and the next upcoming thing is called ASPA. But this was all only stacked upon BGP. There are also new routing protocols, but I personally don't really believe that they will, pick up speed in the next 20 years. If there's a thing called Scion and so on from Switzerland, but
they also tried to replace IPv4, and that didn't work out so well, did it?
Yeah.
So I have two questions. The first one is how much traffic do you have per day? And this
right now, peak.
Yeah.
Peak we're right now at 3 gigabits, but goes.
3. Okay. And the second is more involved, you talked of customers, but that implies to me that you have some sort of business model.
Our business model is basically selling peering ports to them. We basically sell ports on the switches.
Yeah, but I thought you're non-profit, right?
But we still need some money for our operations.
Okay, yeah.
We are not personally profiting from it, but the EV, the club needs to make some money to continue running.
Non-profit mostly means that we're not allowed to just keep a lot of money, get a lot of overhead money and just keep that around.
Yeah.
Right.
There's basically no profit margin. If you, for example, look at our price sheet, that's for industry standards quite low.
Are there any more questions? Yes, in the second row.
My ISP is Pure, for example, at home. Does your existence influence my internet usage
Not
at
yet.
all?
If you lobby with Pure, or how it was formerly called HLCom, that you as a customer would very much profit from a connection to DDX, they maybe send us an email. But or I didn't really talk to them yet. But it's basically if you go to the website, you see what kind of networks are connected, and if you're in one of those networks, then of course how your packets get routed is influenced. But Pure, for example, is not a customer yet, so no.
So I should send them the email.
Yeah,
Exactly.
Yeah,
Do
you
that,
want to
do
do
that,
this?
please. Yes.
Yeah.
The only I think the only ISP that does private connections right now, home connections is and
Sachsen
peers
Gigabit.
with us is Sachsen Gigabit, right? But we'll try to expand, of course.
Because Helcom has infrastructure locally, so it just makes sense for them to connect to us. But it's a process. Sweet.
Yeah.
Awesome.
I don't know if this is a topic for internet exchange providers, but have you ever had the topic with compliance with law?
Not
when it
yet.
comes to surveillance technologies that some, I don't know, internet actors have to plug in order.
Yeah.
You mean the
Shady
black boxes?
No.
Not yet.
Why?
But we might also not be able to tell you if we had, right? So
Okay.
No, but point being is, I think this basically starts becoming a problem when you're getting off size. And I think we are still somewhat far from it. So DKIX definitely has some funny box, but...
you didn't hear that from us, right?
But the threshold basically when you count as critical infrastructure as an IX is quite large. You need to be really large to actually count from the perspective of the government as critical infrastructure.
Okay, thanks.
Like, I don't know what it is, but there's some traffic or peer threshold which you need to cross, and then, BSE comes to you.